Good afternoon, and thank you for tuning into our symposium today. The NASA SEA's 2024 HERA team is proud to present to you our new suite of experiments, H.U.M.B.L.E, or Humans Undergoing Medical and Behavioral Life Experiments. Now to meet the team.
Hi, my name is Evelyn Bahena, and I'm from Fayetteville, Arkansas.
My name is Grace Bittlingmaier, and I'm from Wheaton, Illinois.
My name is Bocanegra, and I'm from Hanover, Maryland.
My name is Tyler Clark, and I'm from Beverly Hills, Michigan.
My name is Ryan German-Dunlop, and I'm from Queens, New York.
My name is Gigi Gordon, and I'm from Bethesda, Maryland.
My name is Kenady Hall, and I'm from Fort Wayne, Indiana.
My name is Joseph Mojica, and I'm from Far, Texas.
Golden leaves in our patch are assembled to appear like a Grecian crown to represent the Greek goddess Hera. The leaves are also aligned into 24 rows for the year of 2024. We put the constellation of Aquarius because Hera is the guardian of Aquarius, and it has 8 total stars that represents each team member. The moon symbolizes the Artemis 5 mission to return to the moon, and the DNA symbolizes the human research we are conducting. Each different color in the DNA strand is associated with the team member.
Space travel is a puzzle harder than humankind has ever had to figure out, and the Artemis program is the most ambitious endeavor NASA has ever imagined. To accomplish Artemis's goal of reaching Mars, many problems must be overcome. Our suite of experiments follow the 5 elements of NASA's Human Research Program, otherwise known as HRP. These elements combat the various hazards of spaceflight to humans, otherwise known as RIDGE. RIDGE includes radiation, isolation, distance from Earth, gravity fields, and hostile environments. We've designed H.U.M.B.L.E to primarily mitigate the hazards we deem the highest magnitude for long-term missions to Mars. We split H.U.M.B.L.E into 2 experiments, H.U.M.B.L.E 1 and H.U.M.B.L.E 2. H.U.M.B.L.E is to be carried out during Artemis 5 before we take the leap to Mars. H.U.M.B.L.E 1 focuses on stress responses, while H.U.M.B.L.E 2 is centered on mitigating space radiation and testing particle accelerator function in space. The 2 experiments are very different, but align in protecting humans in space while promoting humans' goal of reaching Mars.
H.U.M.B.L.E 1 will be focusing on astronauts that will be exposed to high-stress scenarios, where the only choice is a fight-or-flight response. This experiment will be tested on the subject 3 times, which will be before astronaut training, after astronaut training, and after the first spaceflight of that astronaut. This experiment will be focusing on whether the repeated exposure results in the desensitization and/or adaptation to adrenaline. With this result, we will try to understand whether their training worked and to what extent it worked. Finally, the last question is, what stimulants elicit different responses?
This experiment will be carried out by testing epinephrine and cortisol levels through blood and urine samples, blood pressure, heart rate, and blood oxygen levels before and after exposing astronauts to adrenaline-inducing scenarios, such as roller coasters and VR simulations based on lunar missions with different anomalies and conflicts presented, to determine what stimulants elicit different responses in each person. These tests will be completed before candidates are trained, after they're trained, and after spaceflight to compare and analyze any adaptational differences in the results.
Astronauts will be completing a series of surveys once every week for researchers to analyze their behavioral changes and adaptations to stress-inducing scenarios throughout the duration of their mission. These surveys will be completed after a major event or conflict that they were exposed to while in spaceflight. These questions will vary from, do you think your team was prepared for such an event? How did you feel some team members handled such an event? And how prepared did you feel for such an event? Surveys will be completed anonymously in order to receive honest feedback from each crew member. This allows for crew members to analyze their own reactions as well as those of their crewmates to address issues and increase the succession of the mission.
H.U.M.B.L.E 1 would help us to better understand how astronauts will adapt under the prolonged spaceflight conditions of future missions, both mentally and physically. This also allows for better preparation and less risks involved to ensure mission success and completion.
H.U.M.B.L.E 2 is the second study within our suite. This study will focus on space radiation mitigation by testing the effectiveness of 3 different materials in blocking radiation waves. The experiment will test 6 separate skin cell samples from the same astronaut, each exposed to radiation in a different manner. 1 sample will be exposed to no radiation and will act as a control. 1 will be in space surrounded by water. One will be in space surrounded by liquid hydrogen, and one will be in space with no radiation protection. All of those samples will be on the Gateway space station, which will be orbiting the moon. There will also be 2 samples enclosed in particle accelerators, one in space and one on the ground at Brookhaven National Laboratory. The radiation levels of each sample will be measured daily, and the experiment will be repeated for each astronaut on the mission.
The samples will be shaved biopsies, 6 from each astronaut, likely from the arm or leg. They will be stored with cryopreservation so they may last longer and be tested longitudinally. Once collected, they must be put in similar environments for testing in order to maintain minimal variability. The chosen container that each skin cell sample is to be inserted in is a carbon fiber shell with a diameter of 30 centimeters. All 6 samples will be stored in this manner, and 2 of them will contain no outer shield, such that there is a control unexposed to radiation, or in other words, left on Earth, and a control with no extra blockage from radiation on Gateway. For 2 of the tested samples, a 30 centimeter diameter cyclotron will be affixed to the diameter of that inner sphere. One of these will be set up at Gateway and one at Brookhaven National Laboratory. This way, it can be measured if there's a difference in functionality of particle accelerator in space and still test the extent to which it blocks radiation in both places. For the 2 liquid samples, the small shell will be placed into an outer shell, which is 45 centimeters in diameter and also of carbon fiber. The gap between these 2 shells will be fully filled with the desired liquid, either hydrogen or water. It's been determined by prior experiments that the ideal thickness for a shield should be 7 centimeters, so this is achieved by having a difference in diameter of 15 centimeters.
When conducting our experiment, the accelerator on the ground will be used to conduct the same experiment to be more reliable, as the one in space has not been tried as the physics are altered. The skin cells will be collected from each of the 4 astronauts. Some will be preserved to be positioned on the ground, and the others will be launched into space. The different states will be compared and analyzed to show the difference in radiation it was exposed to and the effects that each sample went through. The Gateway and the future Artemis missions will generate about 45 kilowatts of energy from the sun daily. 1.5 kilowatts will be allocated to the cyclotron accelerator daily to keep it constantly generating and to keep it stabilized. We will have a Geiger count, an instrument meant to measure radiation on the Gateway to check the radiation exposure to the cells daily, giving us the necessary data for this study.
H.U.M.B.L.E investigates radiation mitigation, which will be ever more important as we venture beyond the moon towards Mars on our long-term missions. H.U.M.B.L.E tests multiple possible mitigation methods, meaning there are multiple possible routes to success, increasing our chances of finding an efficient mitigator. By working to protect from radiation, H.U.M.B.L.E ensures the health of astronauts as well as the efficiency of mission objectives, as a healthy crew is the most effective one. Further, by testing particle accelerators in space, H.U.M.B.L.E investigates possible differences in operation compared to on Earth. By comparing these differences, it is possible we could better utilize particle accelerators in space for their many uses on Earth, such as cancer treatment, plant and crop biology, and in strengthening materials. Overall, H.U.M.B.L.E is crucial as it addresses the factor of radiation, one which will be exponentially worse the further we go from Earth.
Both studies adhere to the following principles. 1. Social and clinical value. Each research question must justify and convince participants. For H.U.M.B.L.E, there's significance to testing how the Artemis 5 astronauts' mission reacts to stressful flight or fight scenarios. Our study could lead to a helpful addition to the space training depending on our results. For H.U.M.B.L.E, the longevity of spaceflight and the mitigation of space radiation are aspects worth investing in. 2. Scientific validity. We must check all boxes on the study's procedures. Both H.U.M.B.L.E 1 and 2 ensure that participants are equipped with clear methods and are aware of reliable practices. 3. Fair subject selection. For any research, our pool of participants is an important aspect. Each study considered certain factors such as age, sex, health status, and occupation. 4. Favorable risk-benefit ratio. The biggest concern is having our participants in pain or discomfort. Risk can be physical, psychological, economic, or social. For H.U.M.B.L.E 1, we aim to minimize the physical and psychological risk. For H.U.M.B.L.E 2, there's minimal radiation exposure. Overall, We want to get the most out of the study while maintaining our participants' safety. 5. Independent review. A superior and neutral board will review and monitor the study. 6. Informed consent. Participants are informed, completely understand, and are willing to participate in the study. 7. Respect for potential and enrolled subject. The participants will be treated with respect throughout the study.
Both H.U.M.B.L.E 1 and 2 will open opportunities for future research and experiments to be conducted. H.U.M.B.L.E 1 will serve as a guide for astronaut training by adjusting the conditioning astronauts must go through for better preparations for unexpected and stressful scenarios. NASA and other space companies will also be able to gauge a better understanding of the requirements for astronauts in the future, such as performance under stress. This will be done using the provided understanding of adrenaline in space from H.U.M.B.L.E 1. H.U.M.B.L.E 2 opens opportunities for future research in multiple areas. If water is effective, it will open a path to start harvesting ice from the Artemis 4 landing site. If liquid hydrogen is effective, it can also be recycled and used as rocket fuel, effectively turning the gateway into a refueling station. The particle accelerator will lead to the most innovation as it creates possibilities for many future experiments to explore its uses and impacts.
We have had a great time together throughout our SEAS experience. SEAS has been a valuable experience, including going to Fiesta, Texas, High Flight, visiting the HERA site at Johnson Space Center, and, of course, the most funnest of all, playing games together during our free time. We have even met an astronaut called Dan Tani, who was the first ever astronaut that I have personally met. SEAS has been a very valuable experience for us as a team where we have mastered several skills, including communication, time management, and problem solving. These skills will help us succeed in our future careers.
People that our team would like to recognize have helped us in many different ways to make the experience as an SSC's intern amazing. They each have been amazing resources that aided us in creating our project. Firstly, our mentor for this project, Patrick Petty, a mission support specialist, guided us in our research and understanding of HERA and its importance. He truly supported our eagerness to learn and gave us amazing opportunities during this program. Andre Stewart is an Orion spacecraft navigator and analog astronaut that took his time to talk with us about his experience participating in human analogs such as HERA. We would also like to thank our assistant mentor, space educator Becky Fritchie, supporting our ideas and eagerness to reach great heights, ultimately bringing our team together to complete this project. We also had help from Phyllis Friello, an Exploration Medical Integrated Product team member at the Johnson Space Center, who gave us insight on logistics for our project and guided our experimental perspective. Special thanks to Margaret Baggio and Selena Miller, who helped make this amazing program possible and created an environment for students to learn about NASA's opportunities.
We as the HERA team would like to take this time to thank you once again for your attention today. And if you have any questions or comments about our presentation, please leave them below in the chat and we will answer as many as we can in the next 5 minutes. Have a wonderful rest of your day.